welcome to the module on the Single Case Design, or SCD, Study Review Guide, or SRG. What you have in front of you now is the blank Study Review Guide template, which is an Excel spreadsheet that is used to guide the review, or the WWC review, of all single case design studies. You'll see that it has several tabs. The first tab is just an information tab that describes what this is used for, the version, when it was released, things like that. The next tab is the main tab. And the main tab is used to do most of the review of studies. It's got three sections. In the first section at the top, you'll see that there's some information associated with the review. It'll ask for an ERIC ID, which is the study ID on the ERIC search engine, or the full citation if the study doesn't have an ERIC ID. There's also a study ID, which is an ID that comes from the WWC's online SRG. There's a reviewer number and a review date. Below that, there are prompts separated into 4 columns. So the first column of every row for most answers is going to be a prompt. It's column A. Column B is going to be where you provide a short response. Typically, this is a response of, no more than a sentence at most, or it'll be picking a selection from a drop-down box. If you have, if you need to make any explanation, provide supporting information, describe anything you're confused about, or just provide notes for anyone else who may be also working on this review with you, we're going to do that in column C, the third column. And finally, as you go through the review, you always want to provide supporting page numbers in column D. Anytime you're getting information from the study or a study appendix, you want to provide supporting information so that A, if you have to come back to this later and figure out why you made the choices you did, or B, a reconciler or some other member of the review team leadership needs to understand why you made the choices you did, they can track down where you got your information in this study. See, this first section is screening criteria. Or that is, sorry, the overview, where you're going to describe the study review protocol, the topic area review protocol, if you're reviewing a study under a topic area review, and the intervention name. You want to make sure that this intervention name matches the naming conventions used for the OSRG. If you have access, if you're doing reviews to the WWC and you have access to the OSRG, you should have access to the OSRG User's Guide, which describes that in more detail. After you've ensured that you've got the study review protocol, the topic area review protocol, and the intervention name, come down to the screening criteria. The first set of screening criteria are just the general study screening criteria that all studies need to undergo, followed by the single case design screening criteria. The study meets the WWC SCD screening criteria, then you'll move on to discuss the quality of evidence, where you ensure that there are eligible outcomes, you ensure that there are no confounding factors, you go through the various steps of the study review, the SCD study review process. Finally, you will arrive at the section where you provide a study rating. It'll describe, you may need to provide a description of why the study was given a certain rating, describe the ratings for individual designs or the findings associated with those designs. And for studies that meet standards, you're going to possibly estimate effect sizes, probably record some data, describe some elements of the study, and then provide demographic information about the study members. Throughout the study review process, you'll have to use the review tab. The review tab is where you're going to enter information about the various measures, the domains, and whether it meets the WWC requirements. You will also enter information about effect size estimation, if an effect size can be estimated. And finally, there's a column for reliability information. Now, if you are a typical reviewer, you'll never need to touch this. This is for reconcilers to ensure that data that's been extracted from plots has been extracted reliably. The next tab is the data tab. This is where you're going to record data that's either been extracted from plots or has been gathered from tables in the event the tables are available. You're always going to need to, well, we'll talk about that more, but this is where you record data as you're going through a study review. Next, there's a plots tab. Here you want to save copies of any plots that you've extracted data from. Finally, or next, there's an author query and response tab. Here, if you need to send an author query, either because the authors didn't include some information that could potentially change a study's rating or a findings rating, you want to record your questions here. Additionally, if the data is only available in graphical format, you'll want to also author query the tabular data if possible. Finally, there's a summary tab, which will provide an overall summary of findings from the review tab in a sort of condensed format. So I've discussed the Excel spreadsheet in broad terms, but what we want to do next is actually talk about an example study review, how you'd fill out this SRG in the event that you were doing a real review. So before we begin discussing the real study review, I want to just say that we're not going to go through the study or to study it in a lot of detail. I'll refer back to it occasionally, but I'm not going to go over it in intense detail. So if you haven't yet, I would encourage you to pause the video and read through the study in some detail. We believe that this represents a high quality study. They reported a lot of information, and they made it really easy to complete a study review. Not all studies are simple, but this is a great exemplar. Additionally, the authors have published this journal in an open access journal under the Creative Commons Attribution Non-Commercial 4.0 license, which is why we're able to share this with you today. So again, if you haven't yet, go ahead and read through this study, give it some thought, and also take a look at the example study review guide that we've shared with you. Make sure you see if you can sort of understand how the information that's in the study review guide corresponds to the information that's in the study. And so you'll have the things you understand and the questions you have, and you'll be more ready to think and understand the material in this video. Just going to close the template and switch to the example. So, right, the information tab looks exactly the same. You don't ever do anything here. In the main tab, I've recorded the citation for this study. Now, this is an online first study. It's not actually in a volume or issue of the journal. And so this citation is not final. If you're ever in a position where you need to use a citation, and you will only need to use a citation in the event that a study is not yet in the ERIC search engine. If a study is in the ERIC search engine, you can just put the ERIC ID here and you don't have to put the whole citation. But if you're putting an online first citation in this box, you want to go ahead and make a note. This is an online first study, and the citation will need to be updated once it's published in a volume issue of the journal. because we want to make sure that all of our records are pointing to the final location for a study, the final citation for a study. You'll see that I have entered a fake study ID and a fake reviewer number. The usually information like the study ID and possibly the reviewer number will already be filled for you by review team leadership, and so you won't need to do that. This study is not in the OSRG, it doesn't yet have a study ID, and so I've just entered a fake one here, but you want to go ahead and make sure this information is filled and seems accurate to the best of your ability. If you're not sure what goes here, check with the study with your review team leadership. So, you know, I'm pretty comfortable that this is the right citation. This is today's date, and I know that that these are the correct fake ID numbers. Moving on, you want to make sure that the study review protocol version number is correct. At the time of this video, version 5.0 is the most up-to-date study review protocol that governs all reviews under the version 5.0 procedures and standards handbook. However, it's possible that the WWC may yet release future versions of the study review protocol that may offer important information or important details that are needed to review studies. And so you want to make sure that A, the version is correct, and B, that you're always using the most up-to-date version of the protocol. If you're not sure, again, check with review team leadership. So this hypothetical study review is not taking place under any topic area review protocol. So I've left the topic area review protocol name and version blank. Here, I've entered the intervention name. So the intervention in this study is actually a combination of two branded interventions, the Strong Start K through grade 2 curriculum and the check-in, check-out intervention. The version of Strong Start that is used in this study is one that's been culturally adapted to be appropriate for Black students. However, cultural adaptation is a recommended element of the curriculum. So for the purposes of this review, we're treating it as just Strong Start being used in the appropriate way. Moving on to this next section, we're going to look through the screening criteria. Now, here and elsewhere, if the answer is straightforward, you don't really need to provide additional information. So, you know, if your response in column C would just be, yes, the study examines the effect of an intervention, doesn't provide a lot of additional information, don't feel like you need to provide some details there. But anytime that it feels like you've made an assumption, you think that your conclusions might not be obvious to anyone who comes back behind you and is looking through your review, it always helps to provide some detail. So here, I haven't provided any detail in column C, but I have indeed, and for many of these other questions, I provided the page number. You want to make sure you always provide page numbers as much as possible to support the conclusions you're drawing. And so this study does examine the effect of intervention, right? It's examining the effect of the Strong Start K2 curriculum and the check-in, check-out, or CICO curriculum. The report is publicly available. So publicly available in this sense doesn't necessarily mean that it's free. Publicly available can still be behind a paywall, but it needs to be available in search engines to the public in general. Maybe you have to pay for it, but obviously this journal article is free, and I went ahead and I've included a link to the article here in the explanation column. Is the research report complete? Yep. Describes all the details about the study. Is the research report published in the time frame specified in the review protocol or the protocol? Yes. So because we're not reviewing anything in the topic area review protocol, we're just going to default to the study review protocol, which defaults to the in the last 20 years. That's in the handbook. This study was published in 2022, so it's very recent. The research report is in English, so we put yes here. Population, does the study examine an intervention administered to students or learners, teachers, school leaders, other educators, or home or school-based service providers? Yes, right. These are first and second grade students that the study examines. So the location has to be, is the location studying, does the study examine sample members in the United States, the territories or tribal entities, U.S. military bases overseas, and organization for economic cooperation and development member countries, which English is the primary and most used language, right? This takes place in the United States, so yes. Is the focus a program of product, a policy, or practice as described in the handbook? Yes, it is. It's a combination of two products, in fact. Finally, does the study include at least one eligible outcome in a review protocol domain? And yes, this study only has one outcome. It examines externalizing behavior, and that falls in the student behavior domain. It's always a good practice to, in this row, describe the eligible outcomes and what domains they fall into. Finally, at this row, this will fill automatically based on your responses to the screening questions. So if all of these screening questions are answered yes, this will turn to yes. If any of these are no, you can see it'll change to no. But and then you'll need to describe why not. But this study is eligible to be reviewed. You just want to select from the dropdown. There's a few options for describing why the study was not eligible for review that you can use if it was indeed not eligible, but this study is eligible. So we selected the study is eligible for review. And you've sort of already described all the reasons why it's eligible. So there's no need to provide more details in this section of the SRG. Okay. So after you complete the general screening criteria that all studies reviewed by the WWC are subject to, you move on to the single case design screening criteria. There are 3 criteria. The first is, does an individual case serve as the unit of intervention, administration, data analysis? A case is usually an individual participant. Sometimes it's going to be a cluster of participants, such as a classroom or school. And in this study, in fact, the cases are classes. And it meets this requirement. Secondly, does the case provide its own control for the purposes of comparison? And indeed it does. We can see that on page 8 of the study. For the study plot, each case has data both before and after the administration of the intervention, so in the baseline and in the intervention phase. And also in that page, we saw the answer to the third question, right? Was the outcome variable measured repeatedly within and across different conditions or levels of the independent variable? And indeed, we've got repeated data both in the baseline and the intervention phase. So because we selected yes for all 3 of these, this cell here, asking if the study meets the screening criteria, will automatically fill with yes. If we answer no to any of these questions, this will turn to no, but this one does in fact meet the SCD screening criteria. And so we'll come down, we want to select the screening disposition. There are some screening disposition codes for if the study is not eligible for review, the study is eligible for review. So we want to go ahead and make sure we select the study is eligible for review. In the event that a study is not eligible for review, you want to go ahead and provide an explanation, but because of the answers to yes to all these questions, we know why the study is eligible. So once we've completed the eligibility criteria and determined that a study is eligible for review, we know that now it's going to get a rating. And so stage 2 is all about factors that contribute to a study's rating, either the ways that it can meet at the two different, either without reservations or with reservations, or factors that could potentially cause it to the study to receive a rating, or findings in the study to receive a rating of does not meet WWC standards. So the first thing you do once you've determined the study is eligible is that you figure out whether any of the outcomes meet the WWC requirements, because it doesn't have any eligible outcomes, it's not going to meet standards. So the first step for SCD studies is to look at the special inter-assessor agreement requirements for SCD studies. You may recall that the direct observation of behavior is the most common kind of outcome in single case design studies. And so these are usually people recording behaviors rather than like tests, and we need to make sure that it's been recorded faithfully. And so we need intercessor agreement data, right? Data that shows that 2 or more independent recorders generally agree on the outcome measurements. So the first requirement is that IAA data is collected at least once in each phase for each case. And indeed, on page 4, the authors do say that they recorded data, IAA data, at least once in each phase in each case. Did the authors collect IAA in at least 20% of the sessions for at least one eligible outcome? And yes, they collected IAA data for 85% of the baseline sessions and 85% of the intervention sessions, which is well over 20% of the data across all cases and phases. And finally, does IAA meet the minimum acceptable values for at least one eligible outcome? Right, they've only got the one outcome, and in this case, it does. So for the first 2 questions, you don't really need to write anything unless there's something confusing going on or you made some assumptions. But for row 31, where it asks about IAA meeting the minimum acceptable values, you want to go ahead and make sure that you record the IAA values. So they describe the mean agreement, percentage agreement of 92.4% of the baseline phases and 94.2% of the intervention phases, which is well over the 80% percentage agreement that the WWC requires. And so this study does in fact meet the IAA requirements for SCDs. Now, in addition to the IAA requirements, there are general WWC requirements. And so if it meets the IAA requirements, you want to go ahead and go over to the outcome screening and detailed screening section, which is columns A through L of the review tab. You can actually click on this this link, and it'll take you there. So you can see here that I've filled this, and I filled it twice because generally speaking, you want to fill one row per effect size. So if you in other studies, if you're looking at treatment reversal designs, you're going to want to combine all of the treatment reversal designs into one row. That all the treatment reversal designs that contribute to an effect size. But for this one, we're just going to put each multiple baseline design on a single row, because multiple baseline designs that meet WWC standards and have 3 or more cases, as this study does, can have an effect size estimated for them. And so we've got one row for the math class and one row for the reading class, because we've got one sort of design for each type of class. And we've described the measure, the domain the measure belongs to. We've selected the design, and we've selected across participants here, but it's really across units. Some other variations of designs. We described the sample completely, so you want to describe all of the cases or units in the design, the design that you're reviewing the finding from. So the rest of the questions are going to be identical for both rows because they're both about the same externalizing behavior outcome. Okay. This is not a standardized measure, not a standardized test. Standardized tests are a little unusual, but not unheard of in single case designs. Occasionally, when researchers are measuring academic performance, they may use some sort of standardized measure, but typically the answer to this question is going to be no. Is this measure face valid? It's externalizing behavior. The authors have described a set of negative or distracting behaviors in class that they count as externalizing behavior, so it appears to be to have face validity. It's not overlying with the intervention or either condition. The authors measured externalizing behavior. They didn't directly teach the students how to do the outcome or not do the outcome. And typically, these direct observations of behavior in single case designs are not going to be overaligned with the intervention. Even when they're teaching the behavior, when a behavior has to be specifically taught to be performed, such as counting or reciting the alphabet, then it's not considered overaligned with the intervention. If you're not sure, you can always talk to review team leadership. Was there consistent measure and data collection, a data collection process? And really what we're trying to make sure here is, was there consistent data collection between the baseline or no intervention condition and the intervention condition? And in both conditions, the first author and the trained research assistant collected the data. There's, and they did it in the classroom, seated in the classroom. There's sort of no reason to believe that they didn't, that there was not consistent data collection. So we're going to select yes here. Does it meet the IAA requirements? Well, we've already filled that out on the main tab. We know that both of them did in fact meet the IAA requirements, so we selected yes here. So because it's this measure is face valid, it's not overreliant, it has a consistent measure and data collection process, and it meets the IAA requirements, which are the reliability requirements for directly observed behavior. It meets the WWC requirements. So I've selected I've selected yes in both rows here. The next column does not change whether or not the outcome meets WWC requirements. It's simply asking, was the measure independent of the authors or the intervention designers? And this only applies to some domains. The domains that it applies to will be designated in the study review protocol. I believe they are all reading and math domains at this point, so it doesn't apply to the externalizing behavior domain, and so I've selected not applicable. Final column is notes or concerns about the measure. I don't have any notes or concerns about the measure, but if there's some issue in the way that it was collected or some sort of inconsistent definition of the outcome measure, or just anything you might want to ask review team leadership about, or you need to just draw attention to, this is a place to make some notes. All right, so once you've filled out this columns A through L for all of the measures that are potentially eligible for review under the study review protocol, you can go ahead and go back to the main tab. And it asks if there's at least one eligible measure that meets the WWC outcome requirements. In this case, the answer is yes. There's nothing really tricky about that, so I haven't provided any extra details. Is this design free of any confounding factors? There are no confounding factors in this study. Typically, confounding factors in SED studies are going to be if the the person or persons providing the intervention are different. If there's some systematic factor that's present in all of the intervention phases and none of the baseline phases. In this case, the teacher provided instruction in both the baseline and intervention phase, and the first author and the trained research assistant were present for all the parts of the baseline and intervention phases. So there's nothing to suggest there's any confounding factors. So when you select yes, there's no need to describe it. If you selected no here, you'd want to describe what the confounding factor is. The next question asks whether there's a graphical illustration or a table of the raw data available for at least one design. The answer is yes, right? That table on page 8 in figure 1 is a graphical illustration of raw data. Now, we can complete the study review using just the graphical data by extracting data from plots. However, we prefer to have tabular data if possible. So we're going to go ahead and want to send an author query for tabular data. But if we don't get a response to the author query, it will not change the study's rating. We'll just have to use the extracted data. Next, you determine whether the independent variable was actively manipulated by the researcher. This is probably the trickiest element of the study. And here we've selected yes. And so the study authors say that they collaborated with the school principal on the timing of the intervention. And the principal requested that all first graders receive the intervention at the same time. And so that's why if we look back on page 8, we can see that, right, this first grade classroom here and this first grade classroom here are both in the first tier. Now, there's not any particular requirement that they're both in the first tier. They could have been in the second tier or in the third tier. And there's nothing indicating that the principal made the authors start the intervention at the 5th time point. So it's relatively safe to assume that the authors selected the timing of the intervention. And really, we tend to give the authors the benefit of the doubt on this question. And so here we've selected yes, and we can keep moving. Next, you determine whether the design is free of any residual treatment effects, if applicable. So there's only one intervention in this design, so residual treatment effects are not really a concern. So we've selected non-applicable here. Anything else? If you select yes, right, it is free of residual treatment effects, you don't need to say anything about it. If no, you're going to need to talk about why you think there are residual treatment effects present in the design. So you may have seen the screen blink here and the SRG change a tiny bit. I realized that I hadn't recorded the page number that the timing of the intervention came from, and so I went back to the study and determined that the timing of the intervention is described on page 5, and I went ahead and recorded it in this column here. And in fact, this multiple baseline design is also described on page 5. So once we've gone through all of the initial screening criteria, we check the outcomes, make sure there are no confounding factors, ensure that there's a graphical, that the data are available in a raw format, make sure that the independent variable is actively manipulated by the researcher, and that we don't have any residual treatment effects concerns. We're going to move on to the study design. So this is purely a multiple baseline design. Some studies might have combination designs with multiple baseline designs with treatment reversals, or they might have done, multiple studies multiple designs inside of a single study that use different designs. And so, you may select multiple things here. So select yes to all that are applicable, and select no anywhere else. Next, you're going to want to talk about the unit of analysis. So in this study, the unit of intervention, assignment, and analysis was the classroom level. There are 4 total classes in the study. There are 2 first grade classrooms and 2 second grade classrooms. we can see if we go back to the study on page 8, so the first tier of each design is a separate classroom, but the second and the third tiers are actually the same two second grade classrooms. And so I went ahead and I described that here. You always want to talk about the units of analysis and sort of what the focus of the review is. In addition to the authors having specified that the unit of analysis was the classroom, I also want to demonstrate some other features of the SRG later. So this review is going to focus on the two classroom level designs. After you describe the unit of analysis, maybe you talked about what your review is going to focus on. You're going to move on to reviewing the attempts to demonstrate an intervention effect. And so this section has questions that has one question that applies to all designs. It has a series of questions that apply to specific design types. And so anywhere that you see a multiple baseline or multiple probe design question, or every time we see a multiple baseline design question, we're going to answer that question. Anywhere else, we can put not applicable. So this first question is about whether or not there are 3 attempts to demonstrate an intervention effect at 3 different points in time. And so in the case of a multiple baseline design and also multiple probe designs, trigger reversal designs, changing criterion designs, that's really about 3 phase changes at 3 different points in time. And so these multiple probe designs each have 3 phase changes at 3 different points in time. You can see the first phase changes between times 4 and 5, and then between times 8 and 9, and finally between times 10 and 11. So we can go ahead and answer that question, yes. And we're going to mark page 8 here. And page 8 is going to be kind of the most important page for most of the rest of these questions, because they're really going to be typically about looking at the plot. The next question asks about reversal withdrawal designs and changing criterion designs. We don't have to worry about that. It's not one of those designs. So we select not applicable. However, the next question does apply to us. So does the multiple baseline or multiple probe design have a sufficient number of data points to meet WWC standards, right? And there are 2 levels of meeting the standards. It sort of gives a brief description of how you can meet the standards at the 2 different levels. In this design, we have not enough data to meet WWC standards without reservations, but we do have enough data points per phase. So we've got at least 3, and really we've got at least 4 data points in each phase. And that's sufficient for both designs to receive a research rating that meets WWC standards with reservations. It's always good to talk about in these pieces where it could meet at either level, what level the design meets the standards at. And so the next question asks about alternating treatment designs. It's not applicable. The next 3 questions ask about concurrence, the concurrence requirements for multiple baseline and multiple probe designs. The first question asks if data are organized in a way that allows for vertical comparison. And this means that data points at time 1 for every tier must take place prior to all data points at time 2 for every tier, and all data points at time 2 for every tier must take place prior to all data points at time 3 for every tier. You can typically assume that this this standard is met, and actually the authors mention concurrence specifically on page. It's going to be page 5. So I'm actually going to add that to pages here. And so there's reasonable to think that this requirement is met. These 2 other cases have baseline data before the intervention was administered to the first case. So do they have overlapping baseline phases, right? And we can see that yes, right? We've got 4 data points for each case before any other case receives the intervention. So we meet that requirement. Selected yes here. And to the cases that have not yet received the intervention, then you have baseline data collected at or after the time another case enters the intervention. And really, we just want to make sure that, right, that like these 4 cases, that these cases don't all end after 4 data points. because then we don't really, the design is not optimal for the vertical comparison that is a really important part of the visual analysis that primary analysts do. And so we sort of believe that the WWC believes that if that requirement isn't met, it's probably not a high quality design, even if we're not going to be doing visual analysis ourselves. So we've answered yes here. The next question asks about training phases. If there's training of the participants in the study, sometimes there's training phases in the plots, and you need to assess whether the training phases are appropriate for the design and if they should be included as part of the intervention. All of the training in this study took place before the study started, as far as the text indicates, and it was really training of the teachers, not of the students. So this is sort of a not applicable requirement. And again, if you answer no to any of these questions for multiple baseline or multiple probe design, you really need to describe like why it doesn't meet that requirement. What makes you think that? If it's not like really obvious from the plot of the text, and you still always want to provide page numbers again. And then we can ignore the additional criteria for multiple probe designs, right? This is not a multiple probe design, it's a multiple baseline design. And that brings us to the end of the attempts to demonstrate an intervention effect. So far, these designs are eligible the findings from these designs are eligible to receive a research rating of meets WWC standards with reservations. And designs that meet standards with reservations, or that don't meet standards without reservations at this point, don't have to go on to the next step, which is the limited risk of bias step. It's also not applicable to alternating treatment designs like it says here, but we're focused on our multiple baseline design right now. So this next step involves calculating the non-overlap of all pairs. And that's an important thing. So we're actually going to talk a little bit about some example plots where you might extract data from studies and do and estimate the non-overlap of all pairs. I have two plots here that I want to use in this example while discussing the non-overlap of all pairs. These aren't plots from a real study. They're hypothetical plots that could reach the limited risk of bias stage. So you may recall from earlier in the training series that the non-overlap of all pairs is one of several non-overlap effect sizes that have been formulated for use in applied SCD research. Most effect sizes, like writ broadly, not just in single case designs, compare the mean value of one condition, such as the baseline phase, to another condition, such as the intervention phases. So non-overlap effect sizes are instead ordinal comparisons between the data points in one phase. So maybe the baseline phase compared to another phase, the intervention phase, right? And often this the first phase, the baseline phase is called the A phase, and the intervention phase is called the B phase. And the precise nature of the comparison varies between the non-overlap effect sizes. So I'm just going to focus on how this works for the non-overlap of all pairs. So in a traditional comparison between the baseline and intervention phase, you perform a pairwise comparison between each point in the baseline phase, right? Like this point in the baseline phase, and each point in the intervention phase. You'd start with the baseline phase that I just circled, and then move on to the and compare it to the first intervention phase point. For each pairwise comparison, you tally whether the intervention phase points represent an improvement over the baseline phase point. Each improvement is scored as a 1, a lack of improvement is scored as a 0, and exact ties are scored as 1/2. Once you have scored all the pairwise comparisons between the baseline and the intervention phase, you divide the sum of the scores by the total number of comparisons. And this gives you an estimate at the percentage of data in the intervention phase that is an improvement compared to the baseline phase. So if you look at the figure on the left, this is a figure of challenging behavior. And so an improvement in challenging behavior is a decrease, right? We want to decrease challenging behavior. And so this one is very simple. If we were to compare the baseline phase, the intervention phase, every single data point in the intervention phase is an improvement over the baseline phase. Right, so this is a This is a decrease compared to the first point. This is a decrease compared to the first point. This is a decrease compared to the first point. This is a decrease, and so on, compared to the first point. Then we would go to the next data point and compare it to the compare this second data point to every data point in the intervention phase, and these would all also be improvements. Now, and then on the right figure, where it's a classroom engagement, the improvement is an increase, right? We want children to be more engaged in the classroom. And so we compare this first data point in the baseline phase to the first data point in the intervention phase, then the second, then the third, and the fourth, and so on. And once again, all of the data points in the intervention phase are an improvement over the baseline phase. And you can see here that you can probably see in this study that the improvement, well, these are on the same scale, so let's skip that. Now, when we're examining reversibility, the comparison is very similar to the traditional comparison. We're comparing an initial baseline phase to a reversal phase, and we want to make that comparison in the direction of the expected improvement. However, instead of looking for non-overlap, right, when we use this effect size to characterize an intervention, we want as much non-overlap as possible, because that represents the most improvement, or at least that all of the data in the intervention phase is an improvement over the data in the baseline phase. Here, for a behavior to be reversible, we want at least some overlap between, we want some overlap in the reversal phase compared to the intervention phase, because that suggests that behaviors are returning to the same level as in the initial baseline phase, and that there's at least some reversibility. For the WWC, evidence of reversibility for a WWC review is a non-overlap of all pairs of 0.85 or less. Now, if you were reviewing this study for the WWC, you wouldn't look for evidence of reversibility here, because this, even if you were just looking at this top tier by itself, there's not enough data in the third and fourth phase to possibly receive a rating of meets WWC standards without reservations. So we're not going to concern ourselves with reversibility for this data. For examining baseline trend, we are similarly looking for minimal overlap. However, the A phase data in this case are all of the points in the baseline phase except for the last three. So that's, in this case, going to be just these first three data points. And the B phase is going to be the last three data points in the baseline phase. Once again, we want at least some overlap. A lack of overlap from the beginning to the end of the baseline phase would suggest that baseline data are improving or that they have therapeutic trend. We want evidence of minimal therapeutic trend. for WWC reviews, evidence of minimal therapeutic trend is a non-overlap of all pairs of 0.85 or less when we compare the A phase, those first 3 data points, or every data point except the last 3 data points, to the B phase, or the last 3 data points, in the direction of the expected effect. Right, as an example, if we compare this first data point to this first data point to the last 3 data points, we see that the first data point is an improvement. The second data point is not an improvement. And the third data point is an improvement. Sorry, that second data point is actually going to be a tie and then an improvement. And then for the second data point, the first data point in this last 3, so the data point at time 4 is an improvement, then not an improvement, and then just barely another improvement. And so you can continue through making all these pairwise comparisons, adding them up, summing them, right? You can do this all by hand. However, we prefer for WWC reviews to use software because it's probably going to be quicker and less error prone. And so I'm going to demonstrate how to calculate the non-overlappable pairs with software. For the demonstration of software, I'm going to focus on the plot on the left and calculating the non-overlappable pairs for therapeutic trend. When calculating the non-overlappable pairs for therapeutic trend for a design to receive a research rating of meets WWC standards without reservations, all 3 or at least 3 baselines need to have a non-overlap of all pairs for minimal therapeutic or for therapeutic trend of 0.85 or lower. So for software, I'm going to show you the single case effect size calculator. There's the URL is in the SRG. This is a piece of software that was built by Dr. Kristiowski and some of his students. That can be used to calculate a lot of different effects, a lot of different single case effect sizes, including non-overlap effect sizes. So the single series calculator here lets you calculate non-overlap effect sizes 1 by 1. And I also have the data from this plot. And so I have extracted the data from the plot on the left and copied it into a tab that looks a lot like the data tab in the SRG. You can see that I've got in column A, I've got the participant name. In column B, I've got the behavior. In column C, I've got the name of the phase, or at the baseline of the intervention phase. I've got the session number in column D. I've got the outcome value in column E. And then I have rounded values in column F. And these rounded values are important because we are counting ties. We want to make sure that we're using rounded values. When you extract data from plots, there can be just a tiny bit of error. And so you can see, right, these first 6 data points are the baseline data points. And both the first and the 5th data point are 14. They really are 14 in reality. But the extracted values are not exactly 14, right? The data point 1 is 13.99 and data point 2 is 14.02. And if we did that pairwise comparison, this would not be scored as a tie if we used these decimal values. It would be scored as a lack of improvement. And so we want to make sure that we use rounded values on sort of the scale of the outcome. For challenging behaviors, these are counts. And so we know there aren't any decimal counts, right? There's 1, 2, 3, you don't have half of challenging behavior. For something like classroom engagement, where it's percentages, typically you want to also use no decimal points, 0 decimal points, right? So you want to have 1%, not 1.02%. If you want additional decimal points, you can put a number in this additional decimal points column, and it will increase the number of data, or in the real SRG, you can select additional decimals to round to, and it will give you additional decimal points. But by default, it rounds to 0 decimal points in this column F. Okay. So to calculate the non-overlap of all pairs for WAN, I'm going to go ahead and reuse this pane. We want the WAN's first 6 data points. So the A phase is going to be these 3 data points, 14, 13, 21. And you can actually just copy and paste the values here. And then copy let's try again. Copy and paste the values here. Now, we also want to check on the left side here to make sure that we have the right settings, right? So we want to make sure that we've got, we selected the NAP. That's the first effect size at the moment in the app. That could change in the future. So always make sure you've got an NAP selected. And then also need to select the direction of improvement. Now you'll recall that these are challenging behaviors, and so an improvement is actually a decrease. And so we can see that the effect size estimate, or the non-overlap of all pairs estimate, is a 0.83. And we're not super concerned about the standard error or the confidence interval. So I'm going to go over to the right here and record the 0.83. And then I'm going to move down to Kevin. Kevin has, let's see, 1, 2, 3, 4, 5, 6, 7, 8 data points. So the first 5 data points are our new A phase. And the last 3 data points are our B phase. We can see that we get a 0.6. For WAN. And then finally, we're going to get Allison's non-overlap of all pairs. Allison has 1, 2, 3, 4, 5, 6, 7, 8, 9 data points in our initial baseline. So we want to get 6 data points for Allison. 1, 2, 3, 4. Whoops, this here. 1, 2, 3, 4, 5, 6. And then 1, 2, 3. You can see we got a 0.42. Back to the top where I recorded these. It's a 0.42. And so all 3 of these baselines have a 0.85 or lower. So they would all meet the requirement for the minimal risk of bias. And if we were calculating this in a review, we would go down to the this row 68 and record the values of the non-overlappable pairs for any cases where we've done that calculation, and select whether or not it met the requirements. But as I said, for our actual example, for our real study, we don't need to calculate the non-overlappable pairs because the highest possible rating is meets WWC standards with reservations. Once you've completed the limited risk of bias step in the review process, if you need to complete it, some designs won't ever get to this stage. They've arrived at the time to finalize the rating. There are a couple of extra questions, right? There's one about whether or not the study is free of any data or analytic issues that would affect the rating. And this is sort of non-specific, right? We've already covered all of the reasons why a study might receive a lower rating earlier on in the SRG. But if there's some additional concern that you have that you want to talk to your review team leadership with, this is the opportunity to document it. Secondly, the next question is whether or not there's any attrition or sample loss not otherwise noted in the SRG. So here you might note if there's a data points missing from clustered data. So if you've got students in classrooms and you've observed at the classroom level, but sometimes the number of students varies between different data points, you can mention it there. If there's some sort of unplanned missingness in one of the phases, you can also mention it there. If you're looking at a multiple probe design where there's intentional missingness in the data, you don't need to document that here because that's part of the design. This is really, so that's been otherwise noted in the SRG. This is really anywhere that it's not an intentional part of the design, that it's good to mention it here, just to be sure that we've fully documented the study. So first, you want to describe the highest possible rating for any main finding in the study. Now, for most single case design studies, all the findings are main findings. It's unusual to have subgroups because there aren't really enough participants in the study to constitute a subgroup. So typically, the highest possible rating will be the highest rating that any finding from any design in that study. So for this study, the highest rating for that finding meets WWC standards with reservations. And you want to also, so you select the design or the rating here, and then below you're going to select a disposition code. There are several different disposition codes you can select for if the study doesn't meet standards. And if the study doesn't meet standards, you want to actually copy and paste this row and provide as many. Sorry, that's not right. So you can select one of the reasons why the study doesn't meet standards and provide an explanation for the disposition codes. If it does meet standards with or without reservations, describe the contrasts that have those ratings. And so you can see here that I've briefly described the designs, and I've described them together because they are basically identical, just with slightly different classes. And then below that, you're going to describe every single design that you've reviewed in the study. And so in the template, there's only 2 rows here. There's a row for a findings rating, a row for the disposition, and then a description of the study. And if the study doesn't meet standards, you want to provide a row for each disposition code, so you can fully capture all the reasons why a study doesn't meet standards. Oftentimes there will only be 1 rating, because once you've arrived at a finding not meeting standards, you don't need to keep going through all the steps. You can just stop your review, indicate that the study doesn't meet standards, and move on. But sometimes, especially if there's an author query that could change the rating of a study, you might complete the review and end up finding out that there's more than 1 reason why a design or finding doesn't meet WWC standards. So you can see here that I've got 1 row for the math class design and one row for the reading class design. And I've described how they both meet standards with reservations. Finally, there's a row to document any information needed to complete the review for any design. This is really where you describe things that you need to query the authors for. If you're doing the initial review, you want to describe what the information you need and how the ratings could change depending on the availability of the information. If this is the final review guide, if you're like a reconciler or somebody that's finishing the final review of the study, you want to list here the information that was provided or wasn't provided in response to an author query, and how that has how that affects the final rating. Here, I've just noted that we want to get an author query for the raw tabular data at the classroom level, because again, we'd like the sort of the most precise data we can get. If we don't receive a response to the author query, that's okay. It doesn't change the rating of the study. We'll just have to use data extracted from the plots. Once you've finished your review of studies, if any of the studies have met WWC standards, either without reservations or with reservations, you move on to stage 3, where you provide some details about the study, including effect size estimation. So the first step is going to be, if there are any designs where you have not yet recorded any data and you need it for effect size computation, you're going to complete the data tab. Now, studies that are potentially eligible to receive a research rating of meets WWC standards without reservations, you'll have possibly recorded some data earlier on in the review process. But in this case, we typically won't have. Now, you click here, you're taken over to the review tab, and I have actually already recorded, or sorry, you're taken over the data tab, and I have actually already recorded data for the first plot, or I should say not the first plot, but the left design, the design in the math class. And you can see here that I've recorded the participant name or ID, and really this is the unit name in this case. So it's either first grade, second grade class A, or second grade class B. Here in the outcome context or setting column, I've specified that this is externalizing behaviors in math class. Because the outcome for both is going to be externalizing behaviors, you want to provide enough information in this column, and really the combination of these 2 columns to represent a unique combination. And so we'll know that the the rows with first grade and externalizing behaviors in math class are going to be different than the rows that are going to have first grade and externalizing behaviors in reading class. For the phase names, I've just described them as baseline and intervention, and you want to make sure that within a design the phase names match. So all of the data points that belong to the baseline phase in the in the reading class, in the math class design, need to have the same phase name for baselines, right? So there's baseline here, there's baseline here, there's baseline here. If you, for instance, name this baseline first grade, baseline second grade, and baseline second grade B, later on we'd have trouble estimating the effect sizes. Here, I've got the session numbers, and I've rounded these to whole numbers. Because we know that these are only in whole numbers. The percentages I've left as these long decimal places, and we'll talk about this in a minute, but you want to go ahead and leave this. For estimated effect sizes, we want to use all the decimal places we've got. Okay. So as you can see, I've already extracted the externalizing behaviors in the math class. I have not extracted the reading class, and I'm going to briefly demonstrate how to do that with WebPlot Digitizer. You'll recall that there are already some slides about this in the effect size estimation module, but I'm going to go over this real quickly one more time, just so there's a hands-on example. So WebPlot Digitizer is this nice piece of software that lets us extract data from existing plots. You can use the file load images option, or you can drag and drop a plot into the software, which is what I've done here. And when you drag and drop the plot in, these are always going to be 2D XY plots. And so make sure that the 2D XY plot is selected and click Align Axes. And pay careful attention to this order. You want 2 points on the bottom, the x-axis, 2 points on the y-axis, and you want your first point to be on the far left, your second point to be on the far right, your third point to be near the bottom of the y-axis, and your fourth point to be near the top of the y-axis. Click Proceed. I'm going to maximize this so we can see it better. Click this Fit to make it fit the full graphics area. I'm actually going to zoom in a little bit. And so here, for the first X point, I'm going to select as close as I can to the middle of the first tick. And then I can use the arrow keys on my keyboard to move it around a little bit and do my best to get it on the first tick. And then I'm going to use the last actual point, right? So this labeled 15 over here. And I can't quite get it in the middle. Just going to make sure that it's in approximately the same place with reference. So this point's over to the right a little bit. So I'm going to make sure this point's also over to the right a little bit. And my first y-axis point is going to be at the lowest tick. I'm going to try and get it right on 0. And then right on 100. If you messed up anywhere, you can select a point to move it around. But when you're done, you're going to hit complete. Our first x-axis point is on 0. Our second x-axis point is on 15. Our first y-axis point is also on 0. And our second y-axis point is on 100. You want to leave log scale unchecked, unless it is a log scale plot, but I don't think you'll ever see one in SCDs. And we're going to leave the assume axes are perfectly aligned with image coordinates unchecked as well. Hit OK. And you'll see we've got a default data set here. Default data set is not a very good or descriptive name. So you actually want to click on default data set and you have this option to rename it. You want to rename it to something useful. So this is going to be the first grade reading. And also should go up to the axis and also rename it first grade reading. Okay, so we go down and click on data sets. Pardon me. We can manually select the data points. And so you can see as I run my cursor over the plot, in the main area, there's that zoomed in view on the right. And so I want to try and get my data points as close to the center of the each plot point as I can. Looks like it's about as good as it's going to get. And like before, you can move your plot points around, or your points around with a keyboard. So I'm going to move along. My best to select the center, adjusting as I need to. Okay, there we go. All right, so capture all the data points for the classroom level here. You can click View Data to see the data points you've extracted. We can see that this X, right? These are not perfectly correct. There's a little bit of error. This is actually I made a mistake, but I can correct it. You can see here that this starts at 0. It should have started at 1. So if I go back, I maximize this. I go to the axes. I can tweak the calibration. So the points are where I want, but that first X point is actually a 1. So I'm going to hit complete. I'm going to hit 1 right here. So this actually starts at 1, ends at 15. That's where my data points are. So I'm going to hit OK again. Now if I go look at my data, I can see, okay, it starts at 1, and this first data point is like about 86. That looks right. The next one is a 2 approximately, and then an 89. It's about right. A 3 and an 83 looks pretty close, and a 4 and about an 86.5. That's close. Now, you're not going to get it exactly right. You can see there's a lot of decimal points. There is a little bit of measurement error in this extraction process. We understand that. We're okay with it. There's lots of research that suggests that this extraction process is reasonably reliable. Okay. We could, at this point, export the data for the first case on the right, but we're going to keep moving and explore all the data for this design at one time. So we need a different axis for every one of these tiers. So I'm going to go back to the axes, go up to the axes. I'm going to click Add Calibration. It's another 2D XY plot calibration. I'm going to click Align Axes. And I'm going to go through the same process with second grade class A. So there's as close as I can get to the 1, as close as I can get to the 15, as close as I can get to the 0. As close as I can get to the 100. Okay, and hit complete. And now, because these 3 plots are the same, have the same scale, I actually don't need to do anything here. Remember, it's the last time that I entered anything, and I can just hit OK here. Again, you need to rename this to something meaningful. And then we're going to data sets. We're going to add a data set. You want to make sure the axis corresponds to the second grade class A reading axis, axes. And then, like before, we can just go ahead and select all of the data. Okay. And once again, we want to go ahead and view the data and just make sure that it looks like what's in the plot. This approximate 0.1 is about an 86. It's approximate 0.2 is about a 93. It's approximate 0.3 is about a 96. So that looks like it's about right. Nothing's gone horribly wrong in this process. If you start seeing values that are well outside the range of the of what's in the plot, then you just start worrying that maybe the axis is wrong or you did your calibration wrong. Right? If you started seeing like -30 or 120 on this 0 to 100 plot, then you start worrying a little bit outside the the range is okay. So if it's a tiny bit above 100 or a little bit below 0, that's probably just some of the measurement error, right? Negative 0.01 or something like that. That's going to sort of be approximately a 0, and it'll be okay. All right, I'm going to pause recording real quick and jump ahead so you don't have to watch me capture all the data points in the third tier. All right, we're back. You can see on the left, I've made another axis. I've collected all the points on the plot, and I've already off-screen verified that these are, they look sensible and that I trust that these are extracted reliably. So at this point, I've got all the data from the reading class design, and I can export it all at once. I can go up to data sets. I can click export all data here. Then I can download a CSV or a comma separated vehicle. That's a file you can open up in Excel. So I'm going to click download CSV. I'm going to save it somewhere where I know that it is. And then I'm going to go ahead and open it. So this is not exactly organized in the same way that we expect data to be organized in the data tab. That's okay. Now, the data tab is organized in a way that is sensible for reading the data. It's not always the fastest for entering the data. So what we want to do here is I'm going to freeze these panes. So it's easier to see what's going on. Freeze the top row. Yeah, there we go. And I'll actually also freeze the first column. Oh, can't do both at the same time. Okay, well, we'll freeze the top row. That's fine. So the thing that we know for sure is that these data points are going to be sessions 1 through 15. And so we just want to enter 1 through 15 in this row. We know that these first 15 rows are going to be first grade class. So we can just copy, paste it down to the row 64. And these are externalizing behaviors in reading class. Paste it. And then we know from the plot that the first 4 points in this tier are the baseline phase. And then the rest are the intervention phase. And finally, we know that these are the plots. This Y is the outcomes, the Y-axis on the plot for first grade reading. We can copy and paste these into the outcome values. I don't know why these are not. Okay. So that's the first case in this design. The next case, we can do the similar thing. We can grab this 1 to 15. Can grab these externalizing behaviors in reading class. Let's go down to what, row 79. This is second grade class A. And then for the plot, we know that the first, 1, 2, 3, 4, 5, 6, 7, 8 data points are on the baseline. I've just stopped checking. So 1 through 8. And then the remainder are the intervention. And then finally, we can do one more for the last case. Got another 1 through 15. Another set of externalizing behaviors in reading class. Second grade class B. And then from the plot, the baseline phase ends at time 10. And the rest are the intervention phase. All right, that is how you extract data and fill the data tab. Okay, now that we've recorded all the data from this design, we're going to move on to estimating an effect size. The easiest way to estimate an effect size is actually to copy and paste this data into its own spreadsheet. It's a little bit tough for to use a big full SRG as the data that you upload to the tool. So I went ahead and copied and pasted all this data. I've got everything I need here. So that's good. So you want to go ahead and save this data. I'm going to call this example data. This is the data from that the reading class design. And I'm actually going to close it because the tool we're going to use won't want to upload this data while we've got the Excel spreadsheet open. So I'm going to close it now. So if you recall, we've now completed the step of filling the data tab. So if we go back to main, the link below is complete columns M through AI of the review tab to estimate effect sizes, if appropriate. So this is a multiple baseline design. It meets standards with reservations. It has 3 or more cases in it, 3 more units. So it's a design that we could estimate an effect size for. Now, for multiple baseline designs as part of a review, sometimes you won't estimate an effect size at this point. You want to make sure you have the data saved. You may not estimate an effect size because there are more complex modeling options available for multiple baseline designs. But that needs to take part of that estimation, or the use of the more complex modeling options needs to take into account the whole universe of data in the review. And so the right modeling framework might not be available or might not be clear when you're doing your review. In the case of single study reviews, which is kind of what we're treating this as, you do want to go ahead and estimate an effect size, and you want to use the simplest model unless otherwise directed by your review team. So we're going to click here. See, it takes us to column M. I'm going to scroll over a little bit. You'll see that I've already filled this for the first design, the math class design. But I haven't yet filled this for the second design, which is the reading class design. And so this first column asks if we want to change the sign of effect for the meta-analysis, right? So because this is going to be a decrease in externalizing behaviors, we're going to get a negative effect size. But that negative effect size is actually a desirable thing, right? It's an improvement. And so we want the final effect size as part of the synthesis, or to as part of the final review to be positive. So we're going to select yes here. And then we're going to go ahead and go to SCDHLM, the app, which is this shiny app. You can, if you want, copy and paste the URL. I've already got it open. Go ahead and reload it. So this is the SCDHLM app. Much like single case ES, it's made by James Pistiowski and some of his students. You can use whatever tool your review team suggests, but this is sort of the most flexible app. Sometimes it's a web app, sometimes it's a little, the connection can disconnect and you have to start over. Thankfully, we haven't done anything yet. So it's the most flexible app, but it's possible other tools will exist at some point to estimate an effect size. So you can always check with your review team to make sure that you are using the tool they want you to use. And there's a lot of information about how to use this software, how to access SCDHLM. You can access it through our studio. You don't have to use the web app. You can use it locally as well. But I'm going to demonstrate the web app. And the local version looks exactly like the web app. It just opens up a web browser on your computer. So the first step of estimating an effect size is to upload data from an XLSX file. So we're going to select Browse and Example Data. Now, if you are uploading from an SRG with a lot of tabs, you would need to select the Data tab, but there's only one tab in this spreadsheet, so we can just leave it on the default tab. You need to select the study design. This is a multiple baseline design across participants, or we can think of it as units in this case. And then we want to select the case identifier, which is the column participant name or ID. The phase identifier has already been selected. That's phase name. The session number has already been selected. That's session number x-axis. And then the outcome value is the outcome value y-axis. You want to make sure that the correct baseline treatment levels are selected, and they've already been selected. Baseline and intervention. And then you can also, once this has all been selected, you can go over to inspect and make sure that your data looks about right. And this looks pretty close to this second plot over here. The x-axis is a little stretched with respect to the plot in the study, but it's pretty similar overall. So it looks a lot like we've got the right data. You can also look at this data tab here and see some information about the data you're using, you've uploaded. Great. So let me go over to model. By default, we want to use a model that uses restricted maximum likelihood, has a level as a time trend. So there's really no time trend. It's sort of assuming that it's flat in the baseline and also flat in the intervention phase, which is the change in level in the treatment phase. You want a fixed effect for level in the baseline phase, a case level random effect in the baseline phase, and then you want just a fixed effect in the treatment phase. You're going to leave the autoregressive AR1 selected, and if it's not selected, make sure that it is selected, and you want constant variance. Now, below, you can see that the data has been plotted, these solid lines are the model implied trajectories compared to the data. Honestly, this doesn't look like a great fit to me. If you're looking at your data, especially in the context of a single study review where you don't have a lot of other data to make judgments about what the correct trajectory is, if it looks wrong to you like this is an opportunity to talk to your review team leadership and see if maybe there's a different trajectory that should be used. For the purposes of recording this, we're going to leave it as is. But I'm just sort of acknowledging this, that the model implied trajectory doesn't necessarily look great with respect to the data that's observed just in this design. Now, for most SCD studies, we're about done. We're going to go over to the effect size tab, and then we're going to go ahead and record the information in the effect size tab. So we're going to copy, and I'm just going to paste just the value here for the effect size. We're going to get the standard error and paste it here, just the value. We're going to get the degrees of freedom and paste it here. It'll automatically fill out a WWC estimated p-value. We're going to grab the autocorrelation estimate and paste it here. And we're going to, this is the same model specification. It's a simple change in levels with no trend with a case level random effect in the baseline. So the important thing here is that this is actually a cluster level effect size. And this model here does not account for the fact that these are actually data points nested in clusters, not data points nested in individuals. And so when you've got a cluster level assignment study like this one, and the effect sizes at the cluster level, you're going to need to adjust for that clustering. In many cases, you won't have to do anything at all, but some cases you will. So you can see I've already selected yes here for the first one. I'm going to select yes for the second one. Now you need to fill out total number of individuals in the design. There are 13 individuals in this design. I know that because there are 18 individuals in the study, and there are 5 individuals in the first grade class that is not included in this design. So 18 minus 5 is 13. There are 3 clusters or classes in this design. And then here's where you have to sort of get into the nitty-gritty. We're going to go back to the model tab. And if you click on this model estimates tab, you get some information about the study. So we want to get the model estimate B, or the treatment effect, which is here. We're going to paste that in. And then we want to get the variance estimates, or the standard deviation estimates. So tau is the intercept standard deviation. And sigma is the residual standard deviation. The SCB is the standard error of the treatment estimate. Then you need to specify an inter-class correlation. If one is provided in the study that seems appropriate, you can use it, but frequently there won't be an inter-class correlation. So the WWC has some defaults for this. It's 0.2 for academic outcomes or 0.1 for all others. This is a behavioral outcome, so it's going to be 0.1. And then, so we're going to have some automatic, these are components of the correction. You can see that the effect size is a little bit smaller, but the standard error is also smaller. So the p-value won't actually change, but the magnitude of the effect will be reduced. You're going to also want to record the software version that you estimated this under. So you can go back to the front and see this is version 0.71, which I've already done here, and then record today's date. It'll also calculate the improvement index automatically. All right, so after that, you're going to return to the main tab. You're going to want to fill out the rest of the study details. All right, let's maximize this and complete the rest of the study details tab. So the first question is going to be about whether the authors presented effect sizes, and if so, how are they computed? That they didn't, and so we don't really need to say anything more about that. Was the review team able to compute a design comparable effect size? We were in this case. If you have been directed not to compute one, but you know that one will be computed, you can go ahead and put yes here. If you can't estimate an effect size, describe why not and for which designs. And are there any findings ordered for eligible subgroups? So are there any supplementary findings? And there are really never going to be supplementary findings in STDs. So that's almost always going to be no. If there are supplementary findings, then you want to go ahead and describe them here. The remainder of these contextual variables, almost all the way through the end of the main tab of the SRG, are many contextual variables that are entered into the OSRGs. So you want to be very careful that you follow the directions. Anytime there's a dropdown, you want to follow the dropdown sort of exactly. And describe the values for the main analytic sample. I'm going to describe the values for sort of all the cases that were part of the main finding. So there were 18 students in the study. I put 18 here, and that's going to be on page 4, alongside the grades and ages. Whoops. So there are actually first and second grade students here. Right, we've got a drop down that has grades in it all the way through post-secondary and an adult for any adult education that's not post-secondary. If there are multiple grades, you select multiple grades, then you want to record every grade that is in the study or age that's in the study in column C. So I've reported both 1 and 2 here. And I've got 4, page 4 in the pages column. Next, you're going to be asked a bunch of questions about demographic data. For these questions, for these sections, you only want to answer no. You only want to answer these questions about whether it was reported as no. You've got no information. Sometimes you'll have partial information about student race, like they might only report ethnicity for students with a single ethnicity or who reported a single race. They might have collapsed some of the data. The categories might not match exactly to what's in the SRG here. We want to fill it out as much as possible. So if you've got something that you can use to fill these out, you should try and use it. And select yes. For any participants where there's not any information, you can always enter other or unknown race, or other or unknown, whatever the demographic characteristic is, to complete it to 100%. So there is some demographic data on race. I selected yes, and I went ahead and recorded A3 because all the demographic data comes from the 3rd page of the appendix. All the students are Black. No information was reported about Hispanic or Latino ethnicity. The authors did report demographic data on gender. They self-identified 50% as male, 50% as female. There was no information about English language learner status. There was some information about special education programs. A couple of these kids were diagnosed with emotional disturbance and were receiving special education services. And so that's 11% of the sample. The rest of them were not receiving special education services. Nothing was reported about 504 plans. There was there was information about disability status. So again, two of the students were diagnosed with emotional disturbance, and the rest of them did not have a disability diagnosis. So that's the remainder right there in no disabilities. And you'll see as you go down that if you select no in this column, at the bottom of the section, there will be a section, a field that's auto-calculated. If you selected yes, it lets you know whether or not the rows sum to 100%. If you select no, it's not reported, and you just skip on to the next demographic data. So you can see down here where I've selected yes, if I enter like a 10 here, so now it says up to 110%. Oops. It will say no. But if we delete this, adds it to 100%, it says yes. We know this is good to enter into the disability status. Although actually for SCDs, this is you don't have to enter 100%, and so this may look different on the final version that you see. So moving on, this is study report demographic data on free or reduced price lunch status. The answer is yes. All the kids were eligible for free or reduced price lunch. On Pell Grant, there was no information, not surprising, these are young kids. Here we can see that all these kids were in general education classrooms. It was a K-12 public school. It was in an urban area as described by the authors. The authors described this as happening in the South Central region of the United States. You see there are a ton of options here, but the regions here are West, Midwest, Northeast, and South. I've selected South as being the closest thing to match the author's described region. The delivery method was in a small group. This was a product, or really two products. This is both a curriculum and an in-school supplemental. So the Strong Start is a curriculum, and the CICO, the check-in, check-out, is an in-school supplemental intervention. And so you've selected multiple intervention scopes, and we have just described all of the intervention scopes that apply. And then this intervention targets students. In the following fields, you're going to describe some narrative detail about the study. Now, for 162 through support for implementation, so these fields here, these fields are will be part of the WWC website. They'll be part of the single study, the study review page, and so these fields should be complete sentences. Everything should be spelled correctly, and you want to have it be in IAS style if at all possible. You can work with your review team leadership to make sure that this information is authored correctly, but you want to do your best to sort of provide a good overview of what occurred in the study. So this, this piece you may need to work with your review team leadership to get it just right and make sure that you're reporting all of the relevant information. These are good, reasonable examples of what you might want to see in the WWC in these fields to go on to the study page. These final pages are just to provide information from the form. These final fields are really just to inform the other members of the review team about important study details. You're going to describe any maintenance phases if they existed, all the eligible outcomes reported and how they were measured. I've noted here that these are partial interval reporting, who observed it, how it was scored, and then that I've noted that it was the final outcome was the sort of classroom aggregates. I've also described implementation fidelity and how it was assessed and the level obtained. There weren't any outcomes in this study that didn't meet review requirements, and there weren't any outcomes that weren't eligible for review. So I've left a note here. I haven't described anything, and there were no other FCDs in the study that were not part of the review. So didn't have to describe anything here. So that's the end of the main tab, and we are almost done reviewing this study. So let's wrap this up. There's just a couple parts of the SRG we haven't looked at. First is the plots tab. So anytime that you extract data from a plot, you want to go ahead and take a screenshot of that plot and record it in the SRG, because we want to know where you got your data. You don't need to have this level of detail in your SRG. I've put this here to comply with the Creative Commons, the requirements of the Creative Commons Attribution Non-Commercial 4.0 license. But you don't need to provide this level of detail. If you've got a bunch of plots and they're hard to tell apart, you might want to annotate them in some way, but just want to make sure that you've got all the plots that you've extracted data from in this tab. This tab is for describing author queries that you need answered to finish your review. I've just entered the author query for the raw observation level data corresponding to the classroom level aggregates, so that we can more precisely estimate effect sizes. Finally, the summary tab will auto-populate based on what's the values in the review tab. It will, you can see we've got outcome measures of externalizing behavior, the domain is in student behavior. We've got it fills the design, the sample, whether or not we need to change the effect size for meta-analysis and the appropriate. If there's an ICC adjusted effect size, it'll grab that one. If there's not an ICC adjusted effect size, it'll grab the individual level effect size that's that we got from the software. The only thing you need to specify is the study rating for each of these findings. So that completes our final module in the seal case design training series. At this point, you have watched all the videos, and if you intend to become a certified reviewer, the only step remaining is to take the certification exam. You can find a link to that on the main SCD page, the main SCD training page. You will need to be group design certified before you have access to the single case design certification exam. So if you have not yet taken the single case certification or the group design certification exam and passed it, you'll have to do that first. Once you pass that exam, you'll have access to the single case design certification exam. In the event that you become a certified reviewer, you'll have the option of sharing your name and email address along with your certifications on the WWC website. And contracting organizations that perform reviews for the WWC are quite potentially contact you for review efforts. That's it. Thanks for watching.